Everyone, today we will be looking at simplifying square roots. In this, actually, I should say, in this lesson, we'll be looking at simplifying square roots. This is a handy skill in quadratic equations to simplify and kind of clean up a square root and stuff like that. It's also going to be helpful in later lessons as well, where we work with exponents and stuff like that too, different exponents. So let's jump right in. I'm actually going to skip this opening exercise. I don't find it super helpful in delivering the point, but except for these two problems right down here. So we'll look at 5 and we'll look at 6. Okay, and a little bit at these earlier ones too. So if you look at 1a, and I'm going to kind of skip the b and c parts because I think they're just not super helpful. So what does the square root of 16 equal, right? Well, square root of 16 is 4, right? 16 is a perfect square. Since 4 squared is 16, okay, right, if we square root both sides, we end up with this right here. Square root of 16 is 4. Okay, what does the square root of 36 equal? 6. 121 is 11. Root 81, 9. It's going to be helpful when you simplify square roots to know what your perfect squares are. That list you can kind of come up with on your own. So you just take, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and just square those numbers. So you get 1, 4, 9, 20, 16, 25, 36, 49, 64, 81, and 100. It's helpful to know more, too. Okay, the more the better, but, at least up to 10. But then when it comes to something like the square root of 20, right? Square root of 20, well, 20 is between 16 and 25. So we'd expect that the answer is somewhere between 4 and 5, right? But what is the square root of 20? Or how can we simplify it at least? Well, square root of 20 is the same thing as saying the square root of 2 times 10, for example, which, using properties of square roots, we could then say is equal to the square root of 2 times the square root of 10. But this isn't helpful because we also can't take the square root of 2 or 10. However, the square root of 20 is also equal to the square root of 4 times 5, which, using properties of square roots, we can break up that product. And when we do that, lo and behold, we can simplify the square root of 4. It's 2. And the square root of 5, we can't break down any further. 5 is prime. So it's going to have to stay underneath the square root. And this is our final answer. Okay? How is the square root of 28? Well, same kind of idea here. Okay? The square root of 28, there's different ways you could break it up. We could say, for example, that the square root of 28 is 2 times 14. Okay? And again, why are we breaking up in the first place here? Well, the square root of 28 itself is not a perfect square, right? 28 is here between the 25 and the 36, which means our answer is going to be somewhere here in between the 5 and the 6. So since we can't actually take the square root, we break it down like this. Now, is this breakdown helpful? Well, it would be the square root of 2 times the square root of 14. Can we simplify either of those? Well, you might point out that you can simplify the square root of 14, or you can break the square root of 14 down to be like the square root of 2 times the square root of 2 times the square root of 7. But none of these square roots simplify. And so this is an unhelpful way to go. So what can we do instead? Well, another way to break down a square root of 28 is 4 times 7, which, when we break that down, again, using the properties of square roots, the square root of a product is equal to the product of individual square roots there. What's the square root of 4? It's 2. And so this is our answer right here, 2 times the square root of 7. Okay? And again, we can't go any further. That 7 does not break down any further, so we know that we're done. All right, let's try another one. Let's simplify the square root as much as possible of the square root of 50. So again, is 50 a perfect square? Well, if we go back up to our list here, you can see that 50 is between 49 and 64. And so no, it's not a perfect square. But we can break it down. Okay, again, root 50 is the square root of 5 times the square root of 10, but that's not helpful because we can't take the square root of either of those numbers. However, square root of 50 is square root of 2 times 25, which is then equal to the square root of 2 times the square root of 25. And what's the square root of 25? Well, it's 5. So we have root 2 times 5, but we don't normally leave it in this order. Normally we write the order as 5 times the square root of 2. Like so. Okay? We'll see you next video to cover more of these examples.